Welcome to Kognito Key, where we make complex software concepts simple. Today, we're going to dive into a really powerful testing technique. It's something that moves you beyond just hoping your code works to actually knowing it does. This is all about helping you ship with total confidence.
Think about it. We all pour so much time and energy into writing good code, but when testing time comes, are we kind of just crossing our fingers? You know, you run your tests, things seem okay, but there's always that nagging question, isn't there? How can we be absolutely sure we've covered every single logical path and corner case?
Well, there is a smarter way. It's a structured white box testing method called basis path testing, and it was pioneered by Tom McCobb. This is the technique that shifts your whole mindset from "I think it works" to "I can prove it works."
At its heart, basis path testing gives you a systematic way to create a test plan. And the goal? To guarantee that every single statement in your code gets executed at least one time. So it's not about guessing inputs, it's about strategically and methodically testing the very structure of the code itself.
Okay, so to use this method, the very first thing we need to do is create a map of our code's logic. This map has a special name. It's called a flow graph. And honestly, it's our essential guide for navigating all the twists, turns, and decisions hiding inside our program.
Now, you might be thinking of a flowchart with all those different shapes for processes and decisions and data. A flow graph is actually much simpler. It just strips away all that extra detail and leaves you with a clean, abstract map that shows only one thing: the possible paths your code can take.
So each node on this map, which we show as a circle, is like a destination. It represents a block of code, one or more statements that get executed one after the other with no branches or decisions inside it.
And the edges, well, these are the pathways, the actual lines that connect our nodes. They basically chart the flow of control, showing us exactly how the program can move from one block of code to the very next one.
Okay, this is where things get really interesting. These are called predicate nodes. Think of them as the decision points in your code, your if statements or your while loops that create forks in the road. They're the super crucial points that create all the different paths your program can follow.
So we have our map. Great. But how many test cases do we actually need to run to be sure we've traveled down every single path? I mean, we don't want to miss a critical bug, but we also don't want to waste time running a bunch of redundant tests, right?
See, our goal is to find all the independent paths. Imagine you're exploring a new city with this map. An independent path is basically a route from the start to the finish that takes you down at least one street you haven't been on before. We want the absolute minimum number of routes that let us cover every single street.
This is where a powerful metric called Cyclomatic Complexity comes in. It gives us a magic number, the exact minimum number of test cases we need for complete coverage. And it's also a little hint about your code's health. A higher number often means your code is more complex and probably harder to maintain. So let's look at 3 really simple ways to find this number.
The first way uses the graph structure. All you do is take the number of edges, the lines, and subtract the number of nodes, the circles, then just add 2. So looking at our example graph here, we have 11 edges and 9 nodes. Okay, so 11 minus 9 is 2, plus 2, that gives us a cyclomatic complexity of 4. Simple.
Now, for a second way, which is often much easier, you just count the predicate nodes. Remember those forks in the road we talked about? And add 1. Our example graph has exactly 3 decision points, so 3 plus 1 also gives us 4. See? Same result, different method.
And for a final and honestly pretty clever trick, you can simply count the number of enclosed regions on your graph. Just remember to also count the area outside the graph as one region. So if we count them up on our example, 1, 2, 3, and 4. All 3 methods confirm it. We need exactly 4 independent test cases.
All right, now that we've got the theory down, let's put it all together into a practical 4-step process that you can literally take and apply directly to your own projects. Here it is, your 4-step blueprint for totally thorough testing. First, you map your code by drawing its flow graph. Second, calculate that magic number, your cyclomatic complexity. Third, you identify that exact number of unique, independent paths. And finally, you design a specific test case that forces execution down each and every one of those paths. Now, following this blueprint isn't just some theoretical exercise. It has a direct, tangible impact on the quality of your work, and it leads to software that is just far more robust and reliable. What this is really about is making a fundamental shift away from guesswork and towards a structured, logical process. You'll know exactly how much testing is enough, you'll have a solid guarantee that every single line of code gets executed, and ultimately, you'll ship software with so much more confidence and way fewer bugs.
So I want you to take a moment and think about the code you're working on right now. What's the most complex, the most business-critical, or maybe the most historically bug-prone part of it? Yep, that's it. That is the perfect candidate for your first basis path test. Just try it out and see the difference it makes for yourself. If this explainer helped you out, a like and a subscribe would mean the world to us here at Kognito Key. Please share it with a colleague who you think might find it useful. And we'll see you in the next one, where we'll be breaking down another complex topic.